Hello everyone. In this video, we will talk about the hypothesis test for a population proportion. Basically, a company claims 95% of their product meet the specification, and now our task is to carry out a hypothesis test to accept or reject their claim. I will explain the steps for the proportion hypothesis test through this example. A supplier of semiconductor wafers claimed that of all the wafers he supplies, no more than 10% are defective. So this is the population of his product, and he's claiming the probability of defect no more than 10%. So the proportion is 10% or less, basically 0.1. So how do we verify if his claim is correct or not? So we take a sample, a large sample. In this case, N is 400 wafers. And we tested them and we found 50 of them are defected. So X, the number of defected items, equal 50. So if I calculate the proportion of defect in this sample, it is 50 divided by 400. So this will come 0.125, 12.5%. So from the sample, it's already showing the proportion of defect semiconductor is more than 10%. It's 12.5%. But the company may claim if I take another samples, it will probably come less than 6% or 7%. So how do we carry out the hypothesis test for population proportion to either reject or accept the claim? So first, from the central limit theorem, if NP larger than 10 and N1 minus P also larger than 10, then the probability distribution of the variable P hat will have a normal distribution with the mean equal the mean of the population. That means the mean of these samples and other samples. The mean of the proportion will equal the proportion of the population. And the standard deviation, sigma p hat, will be the square root over n. And if I plug values to calculate this standard deviation, it will be 1 minus 0.125 divided by 400, and this will come 0.015. Now, the evidence from the sample, the proportion came 0.125. So it's somewhere here. And they said the population proportion is 0.1. So how do we set now the null hypothesis? Well, the null hypothesis usually go against the evidence of the sample. Since the samples came 0.125, then the null hypothesis will be the proportion of the population is equal or less than 0.1. And the alternative hypothesis will be proportion is larger than 0.1. Now I need to calculate this p-value. Now, if this p-value came very small, like 5% or less, then there is a strong evidence from the sample to reject the null hypothesis. It will be very rare, or the probability is very slim, for a sample to have a proportion 0.125 from a population that has a proportion less than 0.1. And to calculate this p-value, first we're going to transform this normal distribution to the standard normal distribution using the z-score. And the z-score will be p hat minus p over the standard deviation of p hat. And this will be 0.125 minus 0.1 divided by 0.015. And if we calculate these, it came 1.67. So now the standard normal distribution that is equivalent to this one will be where now p instead of 0.1 it will be 0, and instead of 0.125 it will be 1.67. So now I can use the table to find this p-value. which will be the same as this one. If I use the table for the standard normal distribution, p-value will be equal 0.0475. So that is 4.75%. So there is a strong evidence to reject the null hypothesis. That means the proportion of defective semiconductor is more than 10%, because the probability of getting the proportion of a sample equal 0.125 from a population with proportion less than 10% is very small. It's only 4.75%. So then that proportion is more than 10%. So we may not buy these semiconductor. Okay, so the hypothesis test basically, first, X could be the number of success or the number of failure, and it will have binomial distribution. And if we choose a sample with large n and the probability of success or probability of failure is small, but this quantity here, n p0 or n times 1 minus p0 is larger than 10, then X will have a normal distribution. And we calculate the proportion by the number of success or failure divided by n and the standard deviation. We use these. Then we use the z-score to convert this normal distribution to a standard normal distribution. Then we use the table to calculate the p-value. And if the p-value is very small, 5% or less, we reject the null hypothesis. Now the challenge is, how do we set the null hypothesis and calculating the p-value? So you start with the population. They claim the proportion could be either smaller than p0 or larger or equal. So you take a sample, you calculate the proportion of the sample. Now this is p0 here. So if the proportion of the samples comes here, then first we do the z-transform. So this will be equivalent to the standard normal distribution. 0 will be corresponding to here, and this one will be the z. So there are three possibilities. Z larger than 0, then the p-value you will be calculating is this one, to the right of z. And the null hypothesis will go against the evidence of the samples. So if the proportion of the sample larger than p0, then we will set the hypothesis that the proportion of the population actually less than p0. If the sample proportion came less than p0, something like here, then this will be the equivalent z. Then the p-value will be this area to the left of z. And now the sample give evidence that the proportion is actually less than p0. So the null hypothesis will be the opposite, that the proportion of the population is larger than b0. The third possibility is if the claim that the proportion equal exactly p0. So now these samples may come more than p0 or less than p0. So in the standard normal distribution, the z may come here or here. So then the p-value will be this area and this area. Since the sample's proportion did not equal 0, so the null hypothesis will go against the evidence. So it will be the proportion of the population equal p0. And then we calculate these. And if they come less than 5%, we reject the null hypothesis. More than 5%, we cannot reject the null hypothesis. So these are the rule of thumb to choose the null hypothesis and alternative hypothesis for a proportion claim. Let's take this example. A grinding machine will be qualified for a particular task if it can be shown to produce less than 8% defective parts. So this is our population, and the grinding machine, if it can produce less than 8% defective part, we will use it. So we took a sample to test this claim, n equal 300 parts, and we found only 12 were defective. So if I calculate the proportion of this sample, it will be 12 divided by 300. So that is 0.04. That's 4%. So the sample proportion already giving us less than 8%. But that could be by chance. So we have to verify. Is this because the proportion really 8% of the population? So again, that P will have a normal distribution. So let's calculate the standard deviation. And this will be, if we plug numbers, it will be and this should give us 0.0113. So we need to convert this normal distribution to a standard normal distribution. So now we need to set our null hypothesis. Well, the evidence or the sample proportion is less than what they are saying. P will be less than 0.08. So it came 0.04. So I'm going to set the null hypothesis to oppose the evidence of the sample. So the null hypothesis H0 will be the proportion of the population is larger than 8%. Basically larger than 0.08. And the alternative hypothesis H1 equal P less than 8%. So now let's calculate the z-score to convert this normal distribution to a standard normal distribution. So the z-score will be P naught minus P0. If I plug value, it will be, and this equal minus 3.5355. And if I plot the standard normal distribution with now the mean is 0 and this z is somewhere here. And if I use the table for the standard normal distribution to calculate this, p-value will come 0.0002. So that is 0.02%. This is a small percentage. So there is a strong evidence from the sample proportion to reject the null hypothesis. Basically, to get a proportion that is equal 0.04 from a population with proportion larger than 8% is extremely small. That is 0.02%. So I have to accept the alternative hypothesis that the proportion of defective part by this grinding machine is less than 8%. So now I will buy the grinding machine. Okay, this ends this video for hypothesis tests for proportion of a population. Next video, we will talk about small sample tests for a population mean. Thank you for watching and see you next video.